The Richter scale is a logarithmic scale used to express the total amount of energy released by an earthquake. Each number increases on the Richter scale indicates an intensity 10 times stronger. For example, an earthquake of magnitude 5 is 10 times stronger than an earthquake of magnitude 4. An earthquake of magnitude 6 is 10 times 10 or 100 times stronger. In general, a measure of under 5 on the Richter scale is considered a minor earthquake, while a measure over 7 indicates major destruction. Okay. And here's a cute little chart that like shows you how that works out. So if somebody says like, oh, it's an earthquake of a Richter scale of 2, you're not gonna feel that much. There was one a couple years ago that like it was literally at 4 o'clock in the morning and like we barely even felt it. And they were like, yeah, it's an earthquake of magnitude 3. And I thought that was always a lot until I saw this scale. Okay, the Richter scales can be represented by this simplified equation. So log of the intensity equals the magnitude. So here's an example. An earthquake with a magnitude of 1 and intensity of 10 can be represented as log of 10 equals 1. Okay, so over here, we have in 1906, an earthquake in San Francisco was estimated to have a magnitude of 7.8, and we want to find its intensity. Okay, so we're going to take this equation and we're going to substitute in. They say, here's the magnitude of 7.8. So we're going to plug 7.8 into this equation. We're going to say log of intensity equals 7.8. Now we're trying to find the intensity. Well, how do I go from a log to exponential? Because that's how I'm going to be able to solve this. What do I use? We talked about this one last week. We use the circle of life to solve, right? All right, so what I mean by that is right here, there's nothing written. We assume that's a 10, okay, because we work at a base 10. Remember, we started at our base, we raise this guy to the exponent, and then we finish over here. So this is going to be 10 raised to the 7.8 equals the intensity. Well, what's 10 to the 7/8 power? I'm sorry, 7.8 power. Well, let's see. We go into Desmos. And we go 10 raised to the 7.8. So we get 6309574 point, and it's off the screen, 0.448, right? That's a lot. That's 63,095,734. That's big earthquake. Okay. Can you find the intensity of the next one? Take a second, try that one. Okay, so you should have set this up. Log of intensity equals 6.9. And then if we're wanting to solve, we're going to use the circle of life. So 10 raised to the 6.9. So if we go in here, we type in 10 raised to the 6.9. That's going to give us 7943282.347. That's 794,000. Oh, nope, I missed one. 7,943,282. Now, this is a question that always pops up on the test. How many times more intense was the 1906 earthquake than the 1989 earthquake? we've got this number up here, we've got this number down here. What we're going to do is we're going to divide those. Okay, so what I'm going to do is I'm going to type this into my calculator as 10 raised to the 7.8 divided by 10 raised to the 6.9. So I'm going to come in here and I'm going to say 10 raised to the 7.8 divided by 10 raised to the 6.9. So how much more intense is that one going to be? So like roughly 8 times more. Also, you could have done it this way. Remember our exponent rules where we could take, if it has the same base, we subtract those exponents and that would have given us 0.9. Well, if we did 10 to the 0.9, what is our number? 8, right? Or 7.9. Okay, so you could have done it that way as well.
Welcome to the math and science and pH. What is pH? Let's start with what it stands for. The range goes from 0 to 14, 7 degrees. pH is less than 7 in acid, we have pH greater than 7. But why 7?
So fun fact, if your stomach, if you're having issues with your stomach, if you will drink pickle juice, and like just a little bit, not a whole lot, but if you drink pickle juice, it'll actually neutralize the acidity in your stomach. Fun fact. Now you know.
Because 7 is neutral. Well, first off, I had to overcome with which numbers are active and which is I use lucky 7 or 7 is heaven on the pH scale. You remember that 7 is used. And then I know that I also remember by thinking in base jump, you jump from a high place. So base must be a high number. Again, remember, lucky 7 or 7 heaven. Next, let's go to the items that are acidic or base. Milk is slightly acidic, along with apple juice, lemon juice, and stomach acid. Acids that taste very sour. For example, the bases include eggs, baking soda, ammonia, and bleach. And a base may taste bitter, and it could also be sweet. Next, the pH scale has the colors that go along with acids. Bases. Acids are yellow, change to orange, then to red. Bases are green, then to blue, and almost purple. Again, remember B for pH and blue. So what creates acid base? Technically, pH is calculated as the negative log of hydrogen. But it's very simple. Acids gain hydrogen ions and create ammonia. And bases are created by losing hydrogen ions and creating hydroxide. In very simple terms, acids gain hydrogen and bases lose hydrogen. Each number represents a tenfold change in the acidity or basis of the water. Water with pH of 5 is 10 times more acidic than water having pH. If you'd like to know more about pH, you must go and as always, watching and moving that upward. Welcome to Moving Math Science.
Science teachers are going to be so proud of you. Learned so much about acids and bases. Okay, we're gonna skip this and come back to it. Actually, no, we're not. Live. You what? Well, you're also in physics, right? Most of y'all are. Yeah. I don't know. This is some interesting stuff, and if you're able to do it, then you get paid pretty well. My brother is a chemist, and he works for a company. Well, he used to work for the World of Coke. Now he works for a company that produces surgical glue. And like this is what he does all day. I mean, not this, but uses these calculations and does that all day. All right. So on your paper, what I want you to do is I want you to draw this little chart. Okay. And I want you to write down the liquids, hydrogen ion concentration, and then the pH. Okay. So here's a table showing the hydrogen ion concentration in moles per liter and the pH of some different liquids. Okay, so go ahead and write these down, and then we're going to answer a couple of questions. This won't take super long. All right, so we've got water at a pH level of 7. We've got coffee at a pH of, and how do we find this? Well, is there a formula that we can use to help us solve for this? Maybe. Okay, so the formula for finding pH is going to be pH equals the log of the hydrogen concentration. Okay, so in order to find the pH, we're going to say log of 10 to the negative 7 okay, so that's going to be start at your base, go to the outside, finish at the exponent. Okay, and that's how we got that pH level of 7. Okay, not sure why. Oh, I do know why. Because this is supposed to be negative log. Okay, so all of these exponents are going to be what the pH level is. So 5, 4, 3. Okay, I just looked at what seawater's pH level is, and it says it's about 8.1. Okay, so that means that it's going to have a hydrogen concentration of 10 raised to the negative 8.1. Vinegar is going to have a pH level of about 3.76, which means that it's going to have a hydrogen concentration of negative 3.76. Okay, remember, you're writing this down on. All right, so the first question that they ask us down here is, which of the drinks listed, water, coffee, root beer, or orange juice, is the most acidic? Which one is the most acidic? Out of the drinks listed, the water, coffee, or root beer, which one is the most acidic? Root beer? Okay, why? Okay, so it's the lowest pH level, right? Okay, the lower the pH level is, the more acidic it is. That's why it like rots your teeth if you drink too much soda. Yeah, just me. Okay, thanks, guys. All right, so seawater has a pH of 8. Is it more or less acidic than water? Okay, so seawater has a pH level of 8. Is it more or less acidic than water? Less acidic, right? Okay, so vinegar has a pH of 2.4. Is it more acidic or less acidic than orange juice? 2.4. It's more acidic, right? So I need to change that, but that's okay. Yeah. Like the ocean. Mm-hmm. Okay, so here's another table. No, you don't have to write this one down. I just want to show it to you. Okay, so mild detergent has a pH level of 10. Toothpaste has a pH level of 9. Baking soda is 8. Did you know you can use baking soda on your teeth and it whitens it? Okay, I thought that was just a thing my mom used to do. That's fine. All right, blood has a pH level of 7. Milk is 6. Bananas are 5. Tomatoes are 4. Did you know tomatoes are acidic? Did you know tomatoes are a fruit? Okay, there we go. All right, apples 3. It's just because of how those seeds are set up, right? Okay, so write an equation to represent the pH rating in terms of the hydrogen ion concentration H in moles per liter. Okay, so we've kind of already done this. Okay, so we have negative log of the hydrogen atoms equals pH, right? And you want to get comfortable with this equation because what they often like to do is they say, hey, take this equation and rewrite it to solve for H. Okay, get comfortable with that equation. Okay, all right, we're going to jump back to the slides. Okay, so here's a table showing the Richter ratings for displacement recorded by a seismograph 100 kilometers from the epicenter of an earthquake. That's a lot of words. Compare an earthquake rated with a magnitude of 5 on the Richter scale and that rated with a 6. How do their displacements compare? What about an earthquake with a magnitude rate with a 2 and that rated with a 3? Okay, so go ahead and take a moment, answer that question 1. Compare between a magnitude of 5 and a magnitude of 6. How did their displacements compare? All right, so how does a 5 compare with a 6? No, because look, it says 5 on the Richter scale. Where's Richter scale? 5's right here, right? And then 6 is right here. So how do you compare these two displacements? What's the difference? If we have a 10 raised to the negative 2 and a 10 raised to the negative first, how much difference is that? 10, right? Okay, so they have a 6 is going to be 10 times the displacement. Okay. All right, so how does it relate, compared to a magnitude of 2? Okay, so we go from 10 to the negative second, 10 to the negative fifth. So how much of a difference is that? Well, that's 3 in exponent, right? But when we actually plug this in, we have -5 and then -2, right? So how big of a difference is that going to be? Look at the board, I'm telling you. 1,000, right? Okay, so there's an 1,000 times difference in displacement. Okay, And we're going to skip that last question because that last question deals